I'm Elizabeth Rata from the Knowledge and Education Research Unit at the University of Auckland, and my talk is in the series Researching Curriculum Subjects, Understanding How Teachers Plan, Design and Lead the Curriculum. And today I'm going to talk about the Curriculum Design Coherence Model. What I'm going to cover is a description of the model, and then I'll move to the problem that the model addresses, then to the CDC model design process. Then I'll talk about a number of features of the model, and I'll finish with a couple of slides about the knowledge-rich school project. Right, the CDC, or Curriculum Design Coherence Model development. Well, the initial ideas for a design model came from a University of Auckland engineering project that I worked on with colleague Graham McPhail and others, some from the engineering department, and that project revealed a real problem between how the engineering students were able to connect their knowledge of concepts and what they were able to do with that knowledge competencies. And as a result of that problem which we identified, Graham McPhail and I have developed the CDC model in association with other colleagues from the Knowledge in Education Research Project and colleagues from England as well. Now, our purpose in developing this model was to recognise the problem as a subject concepts, content, subject competencies, connection problem. And I've highlighted those words, especially the word connection, because that's the key to the model. We've theorised the model in 2 publications, and at the end of the presentation, I've got a list of references that you can have a look at. And we're trialling the model in the Knowledge Rich School project in New Zealand and in England. Now, what are the propositions informing the CDC model? Well, the CDC model provides a professional development tool for teachers to achieve curriculum coherence and to contribute to their curriculum design expertise. It works by, and here's this word connecting again, connecting subject concepts, subject content, and subject competencies in a logically structured way to create coherence. Highlighted 3 keywords there: connecting, the structure, and coherence, and they're words that will come up throughout my presentation. Now, we use the term epistemic structure. Epistemic simply means knowledge. We use epistemic structure as the term for organising the knowledge that components. Now, knowledge that is the term we use for that subject, concepts, and content connection. So we use the term knowledge that to show the logical way that the connection is achieved. So knowledge that is when subject, concepts, and content are connected logically. So knowledge that, a little bit more about it, because the connection is so important. What is connected? Well, what the knowledge actually is, that's the subject content, what it means, the subject concepts, and then know how to, which is different from knowledge that. Know how to is what can be done with the knowledge, and that's the subject competencies. Now I want to turn to the connection problem. We identified connection as the key problem in curriculum design. So what do we mean by it? Well, this connection problem, interestingly, it affects design in both outcomes-based curriculum approaches and in knowledge-based curriculum approaches. So I want to say a little bit about both. I'll start with a slide about outcomes-based curriculum approaches. The features of these approaches, emphasis on skills, competencies, achievement objectives, teacher as facilitator, student as learner, and it's justified by the various, what Biesta calls learnification approaches, and they include things like personalised learning, inquiry learning, therapeutic learning, learning as a subjective process, always connected to the learner, constructivist approaches to teaching, and so on. Also characterised by assessment, so very much assessment driven because of the achievement objectives approach, and of course skills can be easily measured, so that also contributes to assessment driving this outcomes-based curriculum approaches. Now, Michael Young's identified what he called the blind spot, the knowledge blind spot. These approaches are uninformed by a coherent theory of knowledge. They're more a mixture of ideas which have been promoted by the OECD 21st century approach since the 1990s. And I recommend the recent paper by Megan Lowry to you, which traces the influence of the OECD in promoting these curriculum approaches. Now, the result is curriculum approach which doesn't connect subject concepts to competencies, and that's the problem. Now, the second type of curriculum approaches are knowledge-based, and they're part of this back to knowledge movement that we see in the last decade in both England, New Zealand, South Africa, Australia, and elsewhere. And it's a response to the problems I've identified with the outcomes-based skills approach. Now, Amanda Spielman, the Chief Inspector of Ofsted in England, has identified two categories in this movement. She calls one of them knowledge-led, characterised by more a content list approach. And this was the sort of approach that the outcomes-based was developed as a reaction against, interestingly. Michael Young's recently talked about it being the consumption of knowledge approach, consumption by memorization. And it harks back to that traditional rote learning pedagogy, which people have wanted to get away from. Now, the other category Spielman identifies is what she calls knowledge engaged. Now, this is the big ideas approach. Also a feature in New Zealand. But the problem here is that the concepts are highly generic, not subject specific. And that means it's difficult to link subject specific concepts to the content because, of course, these concepts are highly generic. So it's an approach that's committed to knowledge, but the theory of knowledge underpinning it is not well developed. Then the third approach is what we in the Knowledge and Education Research Unit, along with our English colleagues and others, call knowledge rich. Now, our purpose is to connect subject concepts, content, and subject competencies. And this is where we've developed the CDC model as the design tool to create the connection. It's informed by theories of knowledge differentiation and structuration, and we draw there on Durkheim, for example, Chris Winch, and many others. Now, here's a diagram of the model itself. Notice that there are 4 elements, but before I talk about the 4 elements, I want to draw your attention to the centre of the model. Notice how the word subject, either program, course, or topic, is firmly in the centre. That's because each of the elements refers directly to the subject itself. Our first iteration of the model had academic identity in the centre. And that's still important, and I'm going to come to that as well. Now, 4 elements. First one, subject concepts. Notice the term, as well as subject concepts, we've got a proposition there. Proposition is important, and I'm going to talk more about that. Now, the second element, here we've got the connection, subject concepts to the content. The third element is taking that knowledge that is the subject concepts and content, and connecting it to the subject competencies, the know-how to. Then the final element is evaluating that connection. So here's another connection of the knowledge that and the know-how to. Now I'm going to go through the model and I'm going to use an example. So the design process The model's design process. Element 1, start by selecting a topic. Now, we realised as we developed the model that starting with topics are actually really important, because from topics, well-designed topics, it's possible to build into across the year courses and across the year's programs. That's where you get the cumulative building of the ideas. So the prior learning from one topic is built into the next, built across the years. So we realised that starting with a topic is really important, because the topic provides the object to be studied. This is what Karl Popper calls the knowledge product, the what. What is it we're looking at? Now, the example I'm going to use in the next slides is the tutu poison from, say, Year 10 chemistry. So that's the topic I've decided to select, the tutu poison. So here it is, the chemical formula of tutin. It's the poison of the tutu plant, and here we have the tutu plant. Now, I just want to stop my discussion of the design process and with an aside and talk a little bit about topic selection. Now, this is a specific New Zealand problem. In England, the topics, the subjects taught in schools are from the academic disciplines. So an academic subject is drawn from a discipline and can be verified by the discipline. Now, in New Zealand, we moved much further to what the Ministry of Education here calls a localised curriculum. So we've moved away from specific academic subjects to learning areas. So while the subjects are still within the learning areas, they've lost a lot of their visibility. Now, surprisingly, there's no prescribed content. So we don't know in New Zealand if students have, say, for English, have studied Shakespeare, have they studied our great New Zealand short story writer, Catherine Mansfield? What about one of our major poets, Kone Tūwhare? We don't know. They may well have studied these particular subjects, but the point is, without any prescription in a national curriculum, we don't actually know. The other problem is that there is a random variety of sources. Because the knowledge taught in schools may or may not come from the disciplines, it may come from a random source. It may come from the teacher's own interest, student interest, may come from resources the teacher has easy access to, may come from the teacher's opinion. But the point is, without any prescription at all in the curriculum, we don't know. Now, this has led in beginning of 2020 to the government and many people in the public here too, realising that New Zealand history itself is not prescribed. So with shock and surprise, the government is going to mandate the teaching of New Zealand history from 2022. Who knows whether that will open up other subjects to some degree of prescription? We don't know at this stage. But the problem when there is no prescription at all and no identifiable subject, clearly identified subject with boundaries around it, that it's difficult to verify the knowledge that's being taught because it's from the discipline itself that we have the procedures of accountability that are developed as science, as the disciplines seek to discover the truth. Never, of course, getting there, but science, disciplinary knowledge is characterised by its truth-seeking purpose. So without that, how can the knowledge be accountable? Now, when I get to talk about element 2, this starts to become really important. Element 2, criterion 3. I'll come back to this idea here. Now I'm going back to the CDC design process, back to element 1, this time I want to talk about the proposition. Now, we realised in developing the model that the proposition has a key role to play because it states what the topic is to mean to the students, and it contains the subject concepts where the meaning is located. Now, the proposition captures the logic that is contained in the CDC model design, and it does it through its grammar. So propositional statements contain a subject, that's the what, they contain a verb and a predicate. And the predicate is where we find the subject concepts. Now, the proposition asserts, proposes or states a relationship between the subject concepts and the predicate. So at that point, the verb moves in the centre there to state the nature of the relationship. What is it about the topic that is going to be studied in the topic with the students? And then the predicate tells us, it contains the subject concepts, what the topic is to mean to the students. Now, later on when I get to element 2, I'll talk about content providing evidence of the proposition. But at this stage, just want to focus on the purpose of the proposition. There are some examples here. I'm not going to go through them all. You can see the subject is in green, the verb at the centre, making the relationship, is in red, and then the predicate has the subject concepts there in blue. So for example, second one, the English alphabet. What is it? It is the order of 26 symbols used in writing. So if I was going to teach that topic, then it's those concepts, the concepts of order, of symbols, and of writing that I would ensure the students understood. Now, here is my example. So I'll talk about the proposition with my tutu poison example. So my proposition, which I write, the designer, the teacher writes the proposition in deciding what it is about the topic you want your students to know. Or what I want my students, my year 10 chemistry students to know is this, that tutin, the poison of the tutu plant, is identified by its molecular structure and chemical formula. So it's the molecular structure and it's the chemical formula which are the concepts I want my students to understand. You can see there the grammar of the proposition linking the subject to the subject concepts, the topic to the subject concepts. Now, as well as those key concepts, I will of course develop inferred or related concepts just to build the meaning more. So I'll be talking about atoms and bonding and everything connected to the key concepts of molecular structure and chemical formula. Now, let's move from the proposition to subject concepts. What is the role of subject concepts in the CDC design? Subject concepts are the coherence mechanism to connect subject concepts, content, and subject competencies. So in talking about a connection, I need to be able to say how the connection happens. It's not enough to simply assert there is a connection. I need to explain how the connection occurs. It occurs when those three components are put together. Now, concepts are particularly important because they are the means to generalize to similar content across the years. So the concepts can stay fairly stable throughout the subject, increasing in sophistication as students move through the years and are able to cope with the concepts explained in more difficult terms. But the subject is what changes, the content is what changes, because it's a particular instance or evidence of the generalizable subject concept. For example, the chemical formula that I'm using for the Teuton example, it's applicable to the Teuton poison, but it's applicable to everything that exists in the world: soap, viruses, wood, skin, and you name it. So if you're wanting to teach the concept of chemical formula across the years, because it's such a foundational key concept in chemistry, that concept would be taught across many years, but the content associated with it will change. So we turn to element 2 here. Now, element 2 is a key connection element. This is when the subject concepts are connected to the content to create knowledge that. Now, knowledge that is the epistemic structure. That's what builds, to structure, to build. It builds the knowledge by putting these concepts and content together. Now, the content, as I've just said, is the instance or particular of the concept. It expresses the subject concept in a material or particular form. So a concept-only curriculum, a big ideas curriculum, it's a list of big ideas. Content-only curriculum is merely a list of information. It's in the connection of content to concepts that the relationship of ideas to the real material world is made. And this connection creates the knowledge that. Now, in selecting content, it's not enough just to select it randomly. A point I made when I talked about the New Zealand curriculum. The content selected needs to be justified, needs to be verifiable, and it needs to be accountable. So we've developed 3 criteria to justify content selection. The first criterion is the essential one. That's the best content to express the subject concept. So the content materializes, it provides an instance of the concept. For example, the tutu plant is the material state of the Teuton poison. Now, the second criterion is not always required for all topics. It can be, content can be selected to make the point to students that this type of knowledge is theoretical knowledge. It's always provisional. It's never fixed. Concepts are theoretical. They're not belief. So anyone teaching history or science, for example, will probably show to students that some ideas have been developed in recent times. We're not always held. That development, that truth-seeking nature of the disciplines and of science as ideas are developed across time. For example, the Teuton poison itself was first identified in 1911. So, it's a new theoretical concept. Criterion 3 is a really interesting one, and we decided here not to shy away from the political nature of the curriculum. A curriculum is socio-political. At a certain point, we as a society decide this is what we want our young people to know. And putting it into the model is saying, let's be explicit about this. Let's be upfront about it. Let's say what we are teaching and why we are doing it. So the idea that all young people in a particular country should know the selected knowledge, and that it's the role of a public education system is to ensure that there is some knowledge that's transmitted intergenerationally. The incident with the teaching of New Zealand history has really brought that home to us as a country here. And a national curriculum should contain this essential knowledge. We should know that all children, in the case of New Zealand, whether you live in the far north, whether you live right down in Stewart Island at the bottom, the South Island, that there is some knowledge every child throughout the country is going to have access to. Now I want to move to element 3. Now element 3 is the connecting of the knowledge that, remember the subject concepts and the subject content, to know how to what you do with it. Know how to applying the knowledge. in the model, we've identified two competencies. The first one is a performance competency. So in my example, it could be draw the tutu plant. It could be recall the chemical formula. It could be to describe how tutin works on the nervous system. So it's fairly basic performance activities, but important because you can't do the next competency if you don't have a good understanding of the actual facts, the thing itself. So memorization is an important part of performance competency. Now, judgment competency is the more sophisticated form of know-how-to. And this is where the subject concepts really come into their own as underpinning the competency. So in my example, the student would be able to explain how the chemical formula works through molecular bonding mechanisms and so on. So quite sophisticated, intelligent know-how-to. And the final element in the CDC model, element 4, is the evaluation. So all the elements matter. Evaluation or assessment matters. It's just it comes at the end of the process. And we want to know whether the students know how to, what they're able to do, actually demonstrates what they understand. So we'd be looking at content recall. It's the memorization I mentioned is important, but also skills and performance, important. And then, of course, the judgment. Can the student explain what he or she is able to do in terms of the underpinning concepts? Now I want to turn to section 4 of this talk, and I want to talk about the main features of the CDC model, ones that I've referred to when I've described the model, and I just want to emphasize their importance. First feature is that the model proposes two forms of knowledge. The first one is knowledge that, and that's the subject concepts and the connected content. Of course, there are more forms of knowledge why, knowledge what, and so on, but we focus on, we use the term knowledge that for that main connection. Now, there is also the knowledge form know how to, and that's the competencies, and importantly, competencies in knowledge that. Second feature is the connection. Now, the connection of the subject concepts and the content, that is the epistemic structuring mechanism. It's what builds, the idea of structure to build. That connection, that building, putting them together is the epistemic structure, which ensures the logic of the CDC model. That's where the logic is established. The third feature is the structuring role of the subject concepts. The fact that we're able to generalize to a range of content from these subject concepts. And that's why they play a primary role in the CDC model, with content being the particular instance or materialization of the subject concept. Talked about the importance of the proposition. I come back to it here. The proposition's role in justifying the topic's design. So the proposition must be justifiable. You can't just teach anything. You have to be able to justify it. So the content provides evidence of the proposition's truthfulness by expressing the concepts in a material way. Now, in my example, I propose that tutin, the poison of the tutu plant, is identified by its molecular structure and chemical formula. Well, is it? Is my proposition justified? Is it truthful? I need to be accountable for having made that statement, having made that proposition. So the proposition holds the curriculum designer, the teacher, to account. I can't just make it up. I have to go back to the discipline of chemistry to get that knowledge, to be able to verify it. So knowledge that from a discipline is accountable to the discipline's procedures to ensure the knowledge integrity. Important phrase, knowledge integrity. Knowledge selected from unaccountable sources may promote ideological interests where the teacher or the curriculum designer can simply select content for interests which are not made explicit. The proposition makes the claim for the knowledge explicit. Now, the fifth feature, I mentioned academic identity before. Although we've taken it out of the centre of the model, it actually frames the entire model itself, because we would argue that academic knowledge that's designed for teaching according to its epistemic structure may connect the structure of the knowledge, that epistemic structure, that building of the knowledge inside with the concepts and content. So that's one form of building occurring within the knowledge, to the way intelligence itself develops in the mind, the cognitive architecture. Now this, we're making the point, we're saying may connect, but what we are arguing is that the structure of knowledge is, and we could talk about it as being an analogy to the structure of the mind in terms of the mind developing as logical connections are made. You know, as we understand, as we grow in our understanding of abstract concepts, we make increasingly sophisticated connections. And it's that making of connections in the mind that we are saying is an analogy to the structure occurring within the knowledge, which also is the same process of connecting things logically. Now, that connection of the way the knowledge, the epistemic structure is developed, the structure within the knowledge is connected to the way the mind is also structured logically as patterns are built. This may create a relationship between the knowledge and the student. And that's what we call an academic identity. It may also lead to increased student understanding and to the love of the subject. Many of us have love of a particular subject. It could be English literature, it could be science, it could be maths. Where does that love come from? And we would argue here that it comes from a deep identity with the knowledge within the subject. Now, feature 6, this is the idea of a curriculum design based on a theory of knowledge. We think it's really important that we make explicit the theory of knowledge that underpins the curriculum design coherence model, because it's the theory of academic knowledge which tells us what academic knowledge is, how it works to build the mind, why it works, and that is because of the way it is structured. And then, of course, that theory of knowledge tells us how to design it for teaching, and that's the curriculum design coherence model. Now, I just want to turn briefly to conclude this presentation to comment on the Knowledge Rich School project, which is underway in New Zealand and in England. Now, the questions for the researchers, the Knowledge Project is trialling the CDC model, and the questions for us as researchers are these. Does the project data provide empirical evidence of the CDC model's usefulness as a design tool? I mean, does it work? That's what we want to know. And is the theory of knowledge which informs the model justified? I mean, they're pretty big questions, really important questions, which inform the Knowledge Rich School project. Now, for the schools themselves that are involved in the project, we want to know, does using the model assist in creating coherent and cumulative curriculum within subjects? Is it a good, efficient, sound professional development tool for individual teachers? You know, does it help the teachers? And does it serve as an integrating tool to build department cohesion? You know, is it useful for the science department, the English department, and so on? Now, trialling the CDC model in the Knowledge Rich School project, we have some initial findings from the first 2 years. We have found that it does provide an effective design tool because it makes the design process explicit. The teachers in the project, especially in New Zealand, are able to say to us, we can see what we're doing. We can see how we're putting the knowledge together. In addition, some of our teachers say, look, we're seeing our subject with new eyes. We've been teaching for a couple of decades in some cases, but it's made our subject new to us because it's enabled us to get deep inside it. Interestingly, the trial has revealed how designing for coherence is quite difficult to do. Using the model is not just putting a template onto concepts and content and competencies. It's not a template at all. It's actually a model that the teacher has to apply. So it requires real competency, expertise in using the model. And it helps a great deal if the teachers developing this competency in using the model understand the theory of knowledge underpinning it. Even though it's quite difficult to understand, it's important that teachers know why they're doing what they're doing when using the model. That connection of know how to knowledge that. Now, one of our main researcher from England, Richard Poutney, has coined the term pedagogical imperative, which we've found really useful to use. We've noticed that, especially at the beginning of the project, our teachers tended to want to go straight to teaching matters, saying, how am I going to teach this? What are my learning activities? And we've had to say, hold on there, just wait. Let's design the knowledge first. Once you've designed what it is you're teaching, then you can turn your attention to how shall I teach it? And that's going to be the next stage of the Knowledge Rich School project, linking what has been designed using the model to how it should be best taught. Now, in addition, the project has revealed the danger of taking a content list approach, of going straight to element 2, going straight to the content in element 2, and not making the connection to the concepts. So my final conclusion is, what have we found out about the curriculum design coherence model? We've found that it does work as an effective professional development tool to assist schools with their curriculum development. We've also realised that it's an important training tool for pre-service teachers, those in teacher education, and that's what we're starting to develop, and that's something that's underway in England, looking at pre-service teacher educators and how they can be helped to use the model in order to design their courses. In research now, we have researchers, particularly PhD researchers in both New Zealand and England, using the model, CDC model, as either an intervention tool in their study or an evaluation tool to study the curriculum design in schools they're looking at. And also too, in teaching itself, we have found that some of the teachers in the project are using it as a diagnostic tool to investigate their current curriculum design practices, and this includes teachers who are highly experienced. They say it's a really good way for them to just look again at their own teaching. So I hope this has been a useful introduction to you to the curriculum design coherence model, and my co-designer and colleague Graham McPhail will talk to you in another presentation about how he uses the CDC model to design topics in music.